Okay, an example here of the last two questions that you'll see. I'm asking for the domain and zeros of this function that has some of the stuff we've been looking at. If you took the f of x out of it, it'd look a lot like the problems that we're doing. Now, it's just asking the question in a little different way, and our goal is not going to be to cancel, but to identify these two things. For starters, when you're looking at the domain denominator, the domain will draw our focus to the denominator on this particular function. We're going to talk about things that would make this explode. That's something that's been several months since we've talked about, but in Chapter 3 we've talked about the domain before. The zeros we've also talked about before. That's just going to be the numerator. So we're going to factor both of these and see what happens. When I factor the top, I could pull out an x, and I have x squared minus 16 over on the bottom. I can go ahead and factor that. It's x times x, two numbers that multiply to give us 10 and add to give us 7 will be plus 5 and plus 2. Then I still have some factoring to do on the top. I could break it into x plus 4, x minus 4, over x plus 5, x plus 2. The denominator was done earlier. Now this is completely factored. You notice I can't cancel anything, and that didn't happen on any of our previous problems. But our goal is not to cancel on these. It is to identify the domain and the zeros. Let's start with the zeros. We'll start on the numerator, and I'll abbreviate the zeros with a z. To find the zeros, you're just going to do what we've done before. When we find zeros, we'll set everything on the top equal to 0. That would be 0, negative 4, and positive 4. If you set all three of those equal to 0. The domain, we use a d and a colon to abbreviate that like we have done in the past. The domain, it's easiest to talk about the values that it can't be, because the domain really says all the things you could put into a function. We're going to talk about the ones that don't work instead of the ones that do, because we'd be here forever if we talked about the ones that did. And if I look at this denominator, where it would be 0 is if x were a negative 5 or a negative 2. Those would make those 0. Now, instead of saying equal to, like I've written here, we're going to add a not equal to sign. Again, that's something we visited early in our course together, and it's coming back here. Find the zeros from the numerator, find the domain from the denominator.